Good morning, good evening, and all the participants from the States and from China. Welcome back to Digital Futures 2022. So this year, and the theme of Digital Futures is One Planet. So it's a special moment for us to rethinking on the technology shift and at the same time, the political and the social background globally. So One Planet is a motivation, a special theme. We try to analyze from different perspectives. So we, in our young scholar discussion yesterday, someone mentioned digital future is right now like the metaverse of the architecture education globally. So we have around 300 lectures uploaded to YouTube and Bilibili, and the viewers right now more than 400,000. So that's a very influential platform. So hopefully we invite different expertise and practitioners to present and introduce their knowledge on this platform. So in the future, we're looking forward, not only the students, but also researchers and the practitioners, they can assemble all the new knowledge by themselves. So it's like the future model of study. So thank you for your participation. I would like to firstly introduce the schedule of these 3 weeks. So right now we are in the middle of Doctoral Consortium, and the PhD Consortium is a sharing platform, and this session is specially organized by Tongji University. At the same time, we have some other university organize different session and sharing on this platform. So afterwards, in 25th, June the 25th, we will have a CDR conference, which is the fourth conference organized by Digital Futures. At the same time, in the evening, we have the opening ceremony for the workshop session. And the workshop session will last around 9 days. So that's a fantastic platform. We have over 130 workshops from all over the world. And the closing ceremony and followed by the awards announcement will be on July the 3rd. At the same time, we invited different workshops. We'll present the Metaverse exhibition starting from July the 9th. So welcome, join us to the whole events. So this is the numbers of workshops I just introduced. We have over 130 workshops and more than 268 instructors participate. And the most special of this year is we start to organize the whole events by different language channels, including English, Chinese, Spanish, Portuguese, Arabic, and Turkish, Japanese, Korean, so on and so forth. So we have around 12 channels in the workshop session. So these are the three doctoral consortium we organized, and especially 3 courses from the philosophy, architecture theory, and the new design methodology. So Matthias De Campo is our old friend, and he will make a lecture today. So before that, also, we want to briefly review last week. Actually, we have already introduced Daniel Bolligen, Matt Thompson, Li Shiqiao, and Anthony Picon, Isla Berman, make 7 lectures in 7 days. At weekend, also, we organize 4 young scholar symposium sessions, and including the advanced fabrication robotics, AI, human-machine interaction, hybrid forms and virtual architecture, and innovative structure and materials. So we get really big feedback from this young scholar symposium. And before the lecture, I think we will special introduce the inaugural issue we just launched by Digital Futures community. And the name of the journal is Architecture Intelligence. So Matthias De Campo is also invited as the Deputy Editor-in-Chief and help to organize the intelligent design part, artificial intelligence part. So this issue is a peer review journal for original research papers focusing on the 3 future scenarios, including the smart habitat, virtual habitat, and spatial habitat. And also, we try to introduce the whole life cycles of architecture, including from formation, simulation, optimization, and fabrication construction as well. So welcome to contribute your research, all the PhD candidates and also researchers to this inaugural issue. Thank you. And today, the lecture this morning, and we invited Matthias de Campo, who is associate professor from University of Michigan. The topic is deep architecture, data, dream, and the neural network. Matthias, Dr. Matthias de Campo is the registered architect, designer, and educator. He is an associate professor at Taubman College of Architecture and Urban Planning, University of Michigan, director of ARIL, the Architecture and Artificial Intelligence Laboratory, and affiliated faculty member of Michigan Robotics and MIDAS, Michigan Institute of Data Science. He conducts research on the advanced design methods in architecture, primarily through the application of artificial intelligence in collaboration with the Michigan Robotics and Computer Science Department. Matthias de Campo is a co-founder of Architecture Practice, SPAN. The award-winning architectural designs are informed by advanced geometry, computational methodology, and philosophical inquiry. SPAN gained wide recognition for the design and especially for the Austrian Pavilion at 2010 Shanghai World Expo. And more recently, for the robotic garden at Ford Robotics Building, SPAN's work was featured at the Venice Biennale, Architecture Biennale in 2012 and 2021. Archilab 2013, as well. And also Architecture Biennale in Vienna and Buenos Aires in 2019. A solo show including the formations at MAK in Vienna and exhibition Sublime Bodies at Fab Union Gallery in Shanghai, China. Matthias de Campo was awarded the Accelerate at CERN Fellowship and the AIA Studio Prize, and was elected to the boards of directors at Acadia and IJAC, the International Journal of Architecture Computing. In 2016 and 2020, Matthias de Campo co-chaired Acadia Conference, as well as chairing the 2020 election of Digital Futures. SPAN's work in a permanent action of RAC and MAK in Vienna, the Benetton collection, the Albertina, and the Pinakothek Monash, and several private collections as well. His publishing work includes 2 editions of AD, Evoking Through Design and Machine Hallucination, Architecture and Artificial, as well as the book Neural Architecture, Design and Artificial Intelligence and Sublime Bodies, co-authored with Sandra Maniger. In 2013, the practice expanded its operation to Shanghai, China, where the office is currently working on the building projects of various skills. He earned the Master of Architecture from University of Applied Arts, Vienna, and his PhD from Royal Melbourne Institute of Technology. So today's topic, Matthias will give us is deep architecture data, dreaming, and neural networks. So the neural architecture is a field of architecture that is primarily preoccupied with interrogating the emerging field of ANN as a method of designing architecture. So this lecture presents attempts to to capture the salient features of existing architecture in order to interrogate this data for their underlying architecture qualities. What is meant by underlying architecture qualities. The rational explanation would include aspects such as the spatial layout, sectional distributions of volumes, the dialogue with its environment, the volumetric balance, the material qualities of design, the structural properties, and so on and so forth. All of these things that can be explored with the help of the machine learning process. However, the ambition of projects in the lecture maintains that architecture is more than just assemblage of rational properties. This might explain a passion with new art, which represents excellent mirror of our contemporary age, participating regarding our shared agency with the causal intelligence machines and their observation of the world. Could architecture do the same? Can neural networks help interrogate the latent layers within the geometrical deposits and history of architecture discipline, and then assemblage those found features into the hitherto unseen designs? So thanks. Let's give the screen to Matthias to start your lecture. Thank you.
Thank you, Philip, for the generous introduction into this lecture. I'm very happy to be here. I'm very honored. It's a great pleasure and an honor to be with you and to talk today about some of the research we've done in the last years and some ideas that I've tried to pick up along the way. I would like to thank Philip Yuan first of all, but also the entire team of Digital Futures who are doing amazing work in putting this together. Yes.
Yes. Right now it's I think it goes to the notes, the notes slideshow.
Same problem again. Okay, let's try to figure that out. Let's see. Okay, I think I know how I have to do. In a second. Okay. 1 second. We'll have it in a second.
Good. Yeah, very good.
There's one more thing we need to do here. Oh, the screen sharing stopped, right? I'm sorry. Oh no, I don't see my notes. 1 second. Okay, let's try it like this. Okay. Oh, come on. I'm sorry for that. It's crashing all the time. One more time. We had it before. We have to try it again. That's the usual thing. We just tested it before and it worked perfectly. Now, of course. You still see the entire thing, right? Yeah. Now you see also the presenter notes.
We can see both.
Yeah.
With note.
Again, it crashed again. Okay. It's failed again. Okay. One more time. By the way, I can actually optimize for video if I already add it. And let me see if I can now that I'm here. Do you still see the entire?
We see
screen?
both. We see
Yeah,
both.
unfortunately.
Why is that actually right now? And then we tested it before, it was no problem. Of course, it doesn't work anymore. That is so strange. So if I show you this one here, I cannot see my notes. That's the problem. If I cannot, I could present it like this, but without my notes, which is of course a bit difficult. If I change here to present the view, you still see the notes, right?
Yes, we can see the note.
Just tested it before, it was no problem. I don't know why it's not working now. It's a bit difficult to do this lecture without lecture notes, to be honest, because there's some technical information here which needs to be right. Okay, I'm last time, and if it doesn't work, I'm just going to do it without the notes. Okay.
I think you can make the notes a little bit smaller and just present it. It's also good with the notes.
Okay.
Yeah.
All right. I still don't see the notes. Okay, we're just gonna do it with the notes.
Matthias, one thing you could try is when you go to share screen and click advance, you can share like a portion of the screen, like a window of the screen, so that we could only see the presentation, then you could see the notes. Does that make sense?
Okay,
you could try that.
I can try that. Yeah.
It's under like at the top it says advanced when on the share screen window. You can try that.
Mm-hmm. Advanced, here we are. portion of screen. Let's try that.
Okay, we do see a portion, but we see a strange portion. There we go. That looks good.
All right.
Good. Mm-hmm.
Then thanks a lot, Virginia. What would we do without you?
Who
All
knows?
right. Okay. After this rather unsettling interruption, let's keep on going here. I'm going to try to be a bit faster so we can get also the questions afterwards. So this lecture is called Deep Architecture, Data, Dreaming, and Neural Networks. And basically it subsummarizes some of the discoveries and things I've done or collected in the last couple of years. But maybe to give you a little bit of context of who I am, where I come from, Philip was so kind already to summarize some of the work we've done. Our company was founded in 2003, so we're actually celebrating next year 30 years of span. 20 years of span. 30 years would be quite a bit. And one of the more recent things that summarizes the work that Sandra and I have done over the years was our PhDs that we did at MIT, which are practice-based PhDs, which means that basically you start to create an ontological and epistemological framework around the work that you have done with your office. And it was quite an interesting journey for me to do that, because it somehow started to show a tendency that has been going on in our office for a couple of years now, which was sort of going away from topological, curvilinear, top-down design methods, and rather start to look into emergent methods that allow us to design in a different way than controlling everything that we're doing specifically. And one book that actually summarized a lot of those ideas that we collected until the point that it started to turn is the book Sublime Bodies, which was published with Tongji Press a couple of years ago, and is a really interesting time capsule, I would say, of the work we did until the time when we did the exhibition and the book. A little bit later, I also published this AD, Evoking Through Design, Contemporary Moods in Architecture, which basically summarized some of those ideas in terms of understanding that architecture is more than just an assemblage of functional properties, but also very much encapsulates possible emotional reflections on ourselves as users. And I was interested into how certain morphological and aesthetical qualities can add to this idea. Now I jump forward to basically where did this whole obsession with artificial intelligence come from? That actually started already in 1998 when Sandra Manninger introduced me to the director of the OFI, the Austrian Institute of Artificial Intelligence, and to one of the PhD students they had back then, Arthur Flexer, who you see here in the upper left, who we kept in touch with over the years, debating ideas of how AI could be used in architecture design. The OFI, by the way, is one of the oldest institutes of its kind. It was founded in the 1960s, or is basically like the descendant of the Cybernetics Institute that was founded in the late 60s. So the basis for this lecture are some of the thoughts and theories that I've put together in the book Neural Architecture, published at Oro Editions. I would like to thank Philip for the opportunity to present also this book within the Doctoral Consortium. It starts actually with a chapter called This Building Does Not Exist, an attempt at a theory of neural architecture, to questions such as computational vision as design method, to questions of style in artificial intelligence and architecture. There's a very close relationship between style and machine vision, for example. But it contains also an entire chapter on aspects of language and architecture, which has become very current with the emergence of disco diffusion, Midjourney, and DALL-E. Chapter 6, for example, deals with the important questions of how machines learn to plan, and continues with the questions of applying 3D mesh models in neural network algorithms. A still ongoing research, I would say. I don't think everyone has solved it sufficiently yet, but we're doing steps towards solving that. And the book ends with a statement about the politics of neural networks and artificial intelligence. I think also that has to be considered more widely. At the moment, of course, people are very fascinated with the aesthetical qualities and things that neural networks can produce. But on the other hand, there's like a whole deep discussion necessary about the politics and ethics of AI. Mario Carpo, who you're gonna hear today a little bit later, was so kind to provide the preface for the book, which consists of a fascinating story he wrote about the compositional technique used by an ancient Greek sculptor called Zeuxis in the creation of a Venus statue. And he compares that with how we at SPAN are using GANs in order to mesh together data to get information for projects. Just to give you a little bit about the idea of neural networks or neural architecture, Philip already talked a little bit about it in the introduction. So it's primarily preoccupied with interrogating the emergent field of artificial neural networks as a method of designing architecture. I want to jump over what Philip already talked to you, but I think that it's important to understand that to answer the question whether what the arts can do in terms of really applying a novel aesthetic into their field and a new idea of basically what art can do, if that can also be translated into what we can do as architects. So can actually neural networks really inform our design methodologies in a very different way to what we have seen before? I'm not sure. I guess that maybe you have already heard a little bit about this, like the questions of why use an AI in general, right? So let's go through a couple of basic questions here. Yeah, the basic answer and simple answer to that, or generally speaking, it's better to teach machines how to learn instead of how to do things. Yeah, there is examples that I can mention here. Welding robots, for example. I mean, if you think about it, the car industry started using robots in the late 60s. They started collecting data points on where to weld a while later. So they have millions and millions of data points of where those cars were welded in the past. And because they have so many data points, they basically can teach a neural network not to teach specific points where to weld the car, but to teach this neural network what it means to weld good. What is a good welding point in a car? So because there's millions of examples, it can learn from that. This means that basically at the end of the day, you can have, instead of having like 1,000 cars of the same type in one assembly line, each car that comes down an assembly line can be basically a different model, because you don't have to retrain the robot and the neural network to do this welding over and over again. He knows now. So when a car comes along, machine vision can inform this robot, and the robot is going to make autonomously a decision where to weld. So that's a huge step forward in terms of flexibility, training time, et cetera, which also, of course, means cost reduction. One aspect that I actually pointed out already several times is that the work on AI and architecture is the first genuinely 21st century design method. And if you think about that, all the computational design methods that we've seen in the last 22 years, like the beginning of the 21st century, since the beginning of the 21st century, were basically methods that already existed in the 20th century and were just refined. So things like parametric modeling, agent-based modeling, scripting, versioning, blobs, folds, et cetera, all of that actually already existed in the 20th century and was just refined. But neural architecture is a new paradigm, not only intellectually and culturally, but also technically. So what we see today was not yet possible even a decade ago. So how can I actually sort of prove that statement? Let me jump over this. AI actually consists of a whole family of different ideas. So AI is a very generalist term. There is like a variety of concepts that go underneath that. For example, symbolists who view learning as the inverse of deduction and take ideas from philosophy, psychology, and logic. Connectionists who reverse engineer the brain and are inspired by neuroscience and physics. And evolutionaries who simulate evolution on the computer and draw on genetics and evolutionary biology. There's also the Bayesians who believe that learning is a form of probabilistic inference and have their roots in statistics, and analogizers who learn by extrapolating from similarity judgments and are influenced by psychology and mathematical optimization. Now, the vast majority of things you see these days, and also what you're going to see in this lecture, is actually connected to the idea of connectionism. So this is where the concepts of neural networks emerge, which represent the vast majority of what we see today in machine learning. It's not said that the other approaches are not valid, but the advent of algorithms capable of imitating biological networks and the rise of powerful computing capabilities paved the way for a series of successful applications using artificial neural networks. So let's go deeper into that idea of connectionism. So they are comprised of node layers, right? Containing an input layer, one or more hidden layers, and an output layer. Each node connects to another and has an associated weight and threshold. Now, this is very similar to what's actually happening in our brain, considering how neurons in our brain are actually wired up and how they're connected. So there is this idea that you can take something that you can see in biology and use that synthetically within a computational environment. Yeah, there's of course huge difference. Like, for example, our brain consists of about 86 billion neurons, and they are connected with approximately 10 by the power of 14 of nodes by the power of 15 synapses. So this is the amount of synapses we have, 10 to the power of 15. Yeah. So I could explain a lot here about actually how we know which kind of processes happen in this biological network, in that we actually can read how the electricity goes through that and how they get loaded and discharged and so on, and how those actually are all then translated into a mathematical algorithm. But this is not a computer science lecture, so we're gonna skip over that. But I wanted to mention some of the historical developments that were important here. Things like JMDH, which is the original method for solving problems such as structural parametric identification of models for experimental data under uncertainty. Then autoencoders, which funny enough, they're making a bit of a comeback. Is an unsupervised artificial neural network that learns how to efficiently compress and encode data, and then learns how to reconstruct the data back from the reduced encoded representation to a representation that is as close to the original input as possible. I mean, this was actually something that was super popular a time ago in anomaly detection, image processing, drug discovery, popularity predictions, machine translation. But right now, this concept of feeding backward and forward is being also used a lot by diffusion networks that we're going to talk about in a minute. Then there's the probabilistic neural network, is a feed-forward neural network, which is widely used in classification and pattern recognition problems, right? Time delay networks, which allows the neural networks to have a finite dynamic response to the time series input data. Those are, for example, really popular when it is about making music with neural networks. Yeah? And convolutional neural networks, right? I mean, you've probably heard about them already before, so I'm going to skip over them. And deep stacking networks. These are really the ones that allow us to do like deep architecture developments that enable parallel learning, for example, and is a model parameter of large CPU clusters. And of course, they also have the ability to move along areas of, for example, hallucination, things like that. So what are this kind of neural networks that we actually talk about here these days? Like one of them, I would say that the one that you probably know the best and have heard a lot about are, of course, generative adversarial networks, GANs, that have been very popular in the last 5 to 6 years. And as you might know, that basically it consists of two different networks. You have a generator network and discriminator network. And what happens here is that a generator network takes random noise and produces images that are supposed to be similar to the target samples that it has on disposal. And they go then into the discriminator network, and the discriminator actually decides whether the result of this target sample, whether the results coming from the generator network can be compared to the target samples or not. Are they real or are they fake? And if they're fake, it goes back into, there's a back propagation going on here, back to the generator network that has to go over those images again until the point where the discriminator network says, yes, I accept them as real. Yeah. So probably one of the best known examples of a very successful generative adversarial network is the website "This Person Does Not Exist" that continuously generates new convincing faces. So the AI face generator is powered by a style gun, a neural network from NVIDIA, which was developed in 2018. I have to say that, I mean, there's one thing that I'm very, fascinated and sad at the same time about this, because I'm fascinated how well this actually works, specifically with human faces. At the same time, I'm sad because it's such an exciting methodology, and just to use it to generate human faces is, I think, besides the point of what it actually can do. So how do machines actually see? Like, what if we are going into to understand how we can implement the knowledge that is actually present in data or in images, if you want? How does a machine understand that? Like, how does a machine understand what is a face? Let's start with a simpler example. How does a machine understand what is a 0 that you wrote with your handwriting? Like, every one of you has probably filled out checks that you bring them to the bank and you give them to the cashier person. And I can tell you that not a single person is going to look at these numbers. They're all going to go into a neural network that is going to be able to read those numbers with a high amount of accuracy. But how does a machine actually understand what is a 0, a 7, a 5, a 8, a 7, a 1, and so on, when everyone who writes by hand makes those kind of quirky, unique mistakes? So how this works is that, first of all, a human basically first annotates those numbers. Basically, there's like hundreds and hundreds of images, and we start with a small one, like just a couple of hundred images that are annotated by hand, meaning they're tagged or labeled by a human who knows this is a 0, a 7, a 5, a 8, a 7, and so on and so on. This actually has to go into the thousands to operate properly. And in other like data sets, like for example, ImageNet has already millions of annotated images. Now for the machine to understand it, what it does, it basically divides that image into pixels and into pixel values. So what machines do is they read numbers. That's what they're really good in. And they can compare numbers. So every image that you feed it consists of numbers for a machine. So in this case, for example, it's based on a grayscale histogram from 0 to 255. So you see that this number 8 that we see here is a white number on a black background. So every time the computer sees 0, it's black. And every number that you see showing up in the middle are like grayscale until it's actually white. So, and that particular shape that is done here, it is fed through a network with a variety of layers that actually allows them with a certain accuracy to the neural network to say, yes, that's in this case a 5. Yeah. So what we learned from that is that machines see the world through numbers. That's basically what they do, and that's everything that we base on that is that sort of idea of a numerical value that is represented in a pixel. Okay, after this a little bit technologically heavy part, let's go into something a little bit more, let's say, I don't want to say philosophically or theoretically, but at least a little bit more exciting in my opinion, which is a quick ontology of AI. Like, where does this obsession of humans come from to infuse unanimated matter with some sort of consciousness? It's consciousness, it's not consciousness, but we're gonna go there in a second. I mean, it seems like the desire of us humans to attempt the imitation of thought processes with the help of synthetic matter seems to be firmly wired in our minds. There are many examples for this, but I will point 2 out of them. The first example is the story of the Golem of Prague, which you see here in a beautiful rendition by Paul Wegener, one of the expressionist film directors in Germany of the 1920s. The golem is an animated anthropomorphic being in Jewish folklore that is created entirely from inanimate matter, usually clay or mud. The story goes that Rabbi Judah Löw used this method in 16th century Prague to create a golem to protect the population of the ghetto. What is astonishing to me is that a scroll with magic spells is placed into the golem's mouth to bring him to life. akin to programming or scripting. So language serves to bring inanimate matter to life. And the second example I want to show you is not in folklore, it's not a myth, it's actually true. It's the story of the Turk. The Turk was built in 1770 by Johann Wolfgang Ritter von Kempelen. It was designed to impress Kaiserin Maria Theresia, and it was first displayed in summer of 1770 in Schönbrunn as a chess-playing automaton. On its tour through Europe, it defeated some of the time's most formidable people, such as Benjamin Franklin, Frederick the Great, Charles Babbage. Napoleon Bonaparte actually tried to cheat, but the Turk actually noticed it and wiped all the figures from the board with his arm. So what is astonishing in this story is that when it was touring Europe, it started to inspire more people to engage with aspects of automation and most likely triggered research on automated looms, such, for example, of the ones by Edmond Cartwright, and even inspired probably parts of Babbage's difference engine. So the heritage of the Turk is still present today, by the way. You might have heard maybe from Amazon's AI service, Mechanical Turk. It's a popular service when it comes to labor data. However, there's a little bit here about the hoax about this, because actually the Baroque automaton was not real. It was actually a fake. It was a hoax. There was a person hidden in the plinth of the Turk who was moving the figures. So actually, I like the idea a lot that a Viennese fake hoax basically triggered the first modern wave in exploring artificial intelligence. And if you think about it, also Amazon's Turk is some sort of a fake, because it sounds like it would be an AI that is automatically labeling images, but in fact, it's thousands of people sitting somewhere, I guess in Bangalore, labeling by hand, getting paid pennies for every image they label. Yes, I'm gonna go over Lady Lovelace, but I think what is important is that the marriage of computational tools and cultural exploration is something that almost has always been there, right? We like to understand how we can, how artificial neural networks infuse fresh life into the conversation around the culture of machines capable of synthetic reason. Yeah. So before this potential area of cultural inquiry could be explored, the technological framework had to be created, right? In order to explore the potential of neural networks. One main figure here is Frank Rosenblatt, who you see here manipulating his first attempts to work with the perceptron, which he developed, which basically was the very basic idea of what we see today as neural networks, right? It allowed him to explore tasks such as solving mathematical problems, rudimentary translation, text creation, feature recognition in images, and so on and so forth. And basically, like these very early experiments grew into what we see today, where all these tasks, of course, are much more sophisticated. So I'm going to jump over the fact that AI is all around us. We, in the meantime, should know that. So I'm going to go into something that happened about 20 years after we had that meeting with the people from OFI, from the Austrian Institute of Artificial Intelligence. So we got actually asked, SPAN got asked, if we can design a robot garden. This was asked by the director of Michigan Robotics, J.C. Grisel, and it marked really a milestone in the efforts of really translating some ideas around neural networks to a tangible physical object that was designed using neural networks. A little interlude now about the curve fitting problem. So back to a little bit more technology, I'm afraid. So let's talk a little bit about curve fitting. I don't know if you've heard about that, but Julia Pearl, who is an Turing Award winner, he described once machine learning as nothing but, and I quote, glorified curve fitting. So he might be right, by the way. But it's still a cornerstone of machine learning processes. And most examples you see in this lecture are based in one form or another on curve fitting problems. So curve fitting is a type of optimization that finds an optimal set of parameters for a defined function that best fits a given set of observations. Or let me put it this way, unlike supervised learning, curve fitting requires that you define the function that maps examples of inputs to outputs. And the mapping function, also called the basis function, can have any form you like, including a straight line, which would be a linear regression, which you see here in the first image, a curved line, which is a polynomial regression, and much more. So, and this provides the flexibility and control to define the form of the curve when optimization process is used to find the specific optimal parameters of the function. So why do you think that I'm talking about curve fitting? You remember before that I was saying that this example that you see here is not that exciting to me. Well, it's a great example for robust curve fitting, of course, yeah. But I think that the interesting things happen when you move outside that curve. The perfect curve fitting can produce realistic images. And is the main thing that is used in conventional AI applications. But if you shy away from the perfect curve fitting, something happens, something different, something strange, something surprising, something shocking, maybe something provoking. And I think these are the things that allow to develop a different approach to aesthetics, which I'm very excited about. So let me talk about this in more detail, what I mean by that. Let's talk about AI in the context of culture. So let's first quickly talk about what I understand under culture, what I define, or what a definition of culture could be. So in general, culture is an umbrella term, similar to AI, which encompasses things like the social behavior, institutions, norms, knowledge, beliefs, arts, laws, customs, habits, and the individuals of a particular group of people within an individual of a particular group of people, meaning that those things are shared within a group of people, and those signifiers basically allow us to identify ourselves with a specific culture. Culture is considered a central concept in anthropology, encompassing the range of phenomena that are transmitted through social learning. Learning in the context of AI is, of course, a crucial term, as we heard before, but those aspects include expressive arts like music, dance, ritual, religion, but also, funny enough, technologies are included in this idea of culture. So tool usage is part of the expression of culture. So the concept of material culture covers the physical expressions of culture such as technology, architecture, and art, whereas the symbolic aspects of culture include mythology, philosophy, literature, and science. So tangible and intangible aspects of culture. This is something, for example, that has been researched by Manuel Landa extensively, for example, in his book Assemblage. So AI, I would argue, has an impact on both areas, material as well as symbolic cultures. So let's talk a little bit about the rise of neural art. The title of my book, Neural Architecture, I basically borrowed from the arts. There's already a tendency in the arts called neural art, and there is also a tendency in music called neural music. So as usual, architecture fares really well when we borrow from the arts. So I borrowed the term neural and architecture. You might have seen this portrait before. This is the portrait of Edmond de Bellamy, which was created by the Paris-based art collective Obvious in 2018. It actually became pretty notoriously famous when it sold at Christie's for about $430,000, and allegedly the first entirely AI-based piece of art. By the way, the name Edmond de Bellamy is obviously a tribute to the inventor of the gun, Ian Goodfellow. Bellamy, Goodfellow. Well, anyways, more importantly than what a price was paid for it is, I think, the question regarding really like profound questions that come up when you are using AI technology to create art. Like, for example, about agency, the authorship, the sensibility. So who is the author? The art collective that came up with the idea to use a neural network, the programmer who set up the algorithm, the hundreds or even thousands of artists present in the 1,500 image data set that was created to make this artwork. Who has the copyright of something that was not created by humans? The rise of neural art became very visible after 2018, when artists such as Sofia Crespo, Mario Klingemann, Memo Akten embraced the use of AI as a legitimate form of artistic expression. It cannot be reduced to the visual arts, as I mentioned before, right? I mean, musicians like Olli Herndon, Arca, Yacht, Databots, they all use AI to make their artworks, to make their music. And funny enough, one of the earliest adopters of neural networks to create works of art is actually literature. They already started doing this in the 60s. Even before SPAN, when our practice, even before we knew about these new art tendencies, we started to experiment with things like undertraining, overfitting, data scarcity, just to understand what the neural networks are doing. And after this first modest effort, some crucial questions emerged about the being, becoming, and reality of this architecture design methodology. We had the same questions as the arts about the agency, authorship, and sensibility in a post-human design ecology. So what is the architect's role in a context where the sole authorship is not the human anymore, but when agency is shared? These questions help in the critical interrogation of designs embedded in a world increasingly entangled with the various aspects of AI. They provided the bedrock for the ontology of neural architecture. So in the following, I want to discuss an issue that emerged out of that research, which I think is very important in terms of like a concept or maybe a theory about what we're seeing here, which is aspects of estrangement, defamiliarization, and the problem of the new. So defamiliarization and estrangement also, for example, in a similar vein was applied by the German theater director Bertolt Brecht, and he called it the Entfremdungseffekt. Basically, defamiliarization or Ostranenie is an interesting concept to discuss in architecture design with neural networks. I mean, the term itself was coined in 1917 by the Russian formalist Viktor Shklovsky and describes an artistic technique that provokes the audience with imagery depicting everyday things in unfamiliar or strange ways. The goal was to provide the audience with the opportunity to gain new perspectives and observe the world through a different lens, through techniques that introduce abstraction into the aesthetics of realism. So the concept has influenced 20th century art and theory, including Dada, postmodernism, epic theater, science fiction, philosophy, etc., etc., etc. Jump over this again. So after that concept of defamiliarization, let me talk a little bit about how those are actually present in some of the work we're doing. Just quickly, as an in-between, I want to also mention that the creation of data sets is a crucial problem we have in architecture. Like all the things you saw before, like that were created with images of paintings and so on, they can be created because those data sets exist and they're big and they contain enough data to create well-informed results. In architecture, not so much. We need actually to go ahead and find those things and develop them. But let me quickly go through a bunch of, and I'm going to go quickly through this because I really want you guys to have the chance to ask some questions. Examples of how those ideas and potpourri of things that I showed before are getting applied. We talked a little bit about text-to-image generation. This is an example of a project that I did. It was a competition in 2020 for a high school in Shenzhen in China. When we were invited to participate in an international competition, and what we wanted to apply here is the use of attentional GANs, attentional generative adversarial networks that allow converting text to images. So the competition was actually a perfect reason to do that. We just used basically parts of the program that they were asking for and combined them with some additional prompts that generated imagery like this. And or like what you see on the ground. And then from those images, we extracted with a little bit of grasshopper magic the volumes. So unfortunately, all those things do not work yet really fully in 3D. We're working on that, but this is an in-between step where we had basically images that were then translated into 3D models. It also showed us very clearly that GANs are not able to generate interior and exterior at the same time, but only one of those. So there's a lot of things that need to be concatenated in order to really get a fully 3D modeling suite basically out that is basically informed by AI. But I think we're going to get there sooner than later. The approach of using attentional GANs for design also was published in a paper at the 2021 CADRA conference. But it's actually amazing how much happened in the little time since we did this competition, which was basically 2020, to what's happening right now. The emergence actually of diffusion models is a game changer in terms at least of visuals. And you might have heard about disco diffusion and Midjourney, who are becoming more and more prevalent in the last even just weeks, I would say. People are churning images by the second out and posting them all over the place. It's an exciting time to use those. So how do they work? Basically, it started with something called automated image captioning in 2015, when somebody figured out if we have like a ton of annotated images, and I told you before, for example, that ImageNet has by now, I think, millions of annotated images, we can have a neural network understand what the scene is actually, what the scene is, what it's seeing, not just in details of there's a person, there's a lamp, there's a statue, but what is the whole thing? So the automated caption in this case was people walking on a bridge. Yeah. But what happens if we turn the whole thing around? What if we say people walking on a bridge and then we let the neural network generate the image? I mean, just reversing the direction of information. This is an idea that has been repeatedly used, like GANs operate like that. Deep dreaming operates like that. So there's like a variety of concepts that do that sort of reverse of information thing. It's a good trick, it seems. This was actually developed by Elman Mansinov and others at Amazon Web Services. And his main interest was not necessarily to create, recreate existing scenes, but to create novel scenes. That is really, really exciting. And of course, it was published in a paper. I think these were the first attempts they made to use prompts to create images. You can see it's not particularly sharp. It's also very small resolution. This is, by the way, one of the recurring problems in working with neural networks, the resolution of images. I'm not going to repeat here like how all these different neural networks operate, but I'm just going to go to the diffusion model. So diffusion models are inspired by non-equilibrium thermodynamics, actually. They define a Markov chain of diffusion steps that slowly add random noise to data and then learn to reverse the diffusion process to construct desired data samples from the noise. I don't know if this tells you anything. I hope this next image is going to be a little bit more clear. So we all know that, for example, you can add noise to images, right? You can take an image like here, Gary's Bilbao project, and in Photoshop, basically, there is a Gaussian noise algorithm, just a filter. And if you crank up the filter more and more and more, it will basically end in random noise, right? So what diffusion models do is they reverse the process. Basically, they take a random noise image and then start to organize the pixels in a way that they actually work with the prompt that you gave it. So this is, by the way, a process that's going back and forth all the time. So it's not just one direction or the other, but it's actually really going back. It's really a back and forth process. Okay, so what are we doing with that? Let me show you a couple of examples of recent things. Like you saw the one that when we did this high school, right, which was very abstract, very colorful, but completely abstract, right? Now, I used here in Midjourney a prompt titled "Photorealistic Palladio Villa by night in rain, trending on Art Station, 4K, high detail, beautiful light." And now you're getting things like this. So it obviously learned a lot in the meantime to really understand far better how this operates. Actually, I don't think this is Midjourney. I think this is actually Disco Diffusion. So also between Disco Diffusion and Midjourney, that's already a step forward. But talking about aspects of estrangement, these are the things I'm interested in. The areas where the machine isn't really able to produce a convincing image, but actually more or less guesses what it could be. So in this part of the image, the curve fitting didn't work so well. And that's exactly where I think the interesting things happen also in terms of architecture. Unfortunately, it also means that you can imitate things very easily. So if you prompt Mies van der Rohe building, it will create things like this. They're quite convincing as Mies van der Rohe images, which means also that we're going to see tons and tons of imitations of existing architecture. More complex prompts give you really interesting results. Looking down a fantasy canyon, many buildings, heavy rain, etc. And you get quite convincing images here. So, I think that for concept designers, this must be quite a scary moment now, because concept designers are going to have a hard time to compete with this. Architecture is a bit different because architecture has so much more subtleties in terms of understanding how it operates, how it works, how the material construction is, and so on. So there are many, many layers that we still have to cover and talk about before we can really say that it will produce anything of meaning. So for example, here, a prompt like section drawing for an opera house. And yeah, they look kind of like sections, but this is not an opera house. It's probably not going to work either, but it might be useful as a starting point. You know, I mean, I think I consider these machines not so much something that will replace human ingenuity, but that actually expands human ingenuity, inspires human ingenuity. And you can have a lot of fun with it, like doing things like this, just asking an AI, what's the most beautiful house in the world? And that's the most beautiful house in the world according to an AI. All right, so this actually, yeah, no. Anyways, you can really produce incredible amounts of imagery very, very fast using this new text-to-image conversion neural networks. By the way, it's not a GAN. I'm gonna talk about this in a second. Yeah, it's actually not a GAN. Yeah, it's a diffusion model. So it's a different idea. Okay, so all of this been seeing. Let's quickly go and talk about the elephant in the room, which is AI and creativity. So how creative were those results that we just saw before, right? Do they actually really comply to ideas of creativity? Are we imagining that they're creative? We all know things like the example of the Bob and Alice experiment, where two neural networks basically were tasked to discuss banking and economy issues. The guys went away overnight, came back the next day, and this guy and the two neural networks had invented a new language. That's how it was actually presented in the newspapers. I was very excited when I heard this for the first time, I think 2017, until I figured out, or with a little bit more of critical thinking, that might not be true. First of all, it's English, so it's not a different language, right? I still can see I, everything else. It's English. Secondly, we don't know what it means. It could be also just, you know, garbage. It could mean nothing, yeah? And third, it might be just a bug in their code. So what we consider here is a possible creative move, which is like the invention of language. When you look at it close up, it might not be that. A little bit different is the whole discussion around AlphaGo, which is very interesting. This is the famous move 37, which actually really pioneered a new idea of playing Go, which, by the way, they're called they're actually called AlphaGo moves these days. It was very surprising. It was different. It was innovative. And the humans actually needed a little while to understand why this move was so ingenious. But the moderator here, Myung-Kwan Kim, he actually then suddenly exclaimed, wow, that was a creative move. So it actually solidified the myth that AlphaGo might have creativity. Well, big question here. I'm not going to go through the whole history of the research on creativity. This is like 2 more lectures, not just 1. So I'm just quickly going to say that what we see here might be a misconception of what creativity could be, meaning that it might be an interesting move, but it also means that it might just be a really, really very well-trained neural network. That I know it's a combination of a variety of networks that were in fact playing here, but maybe it just found out the best possible way and the best possible move just not to lose the game because it's trained on not losing the game. So maybe it's not creativity, maybe it's just really, really well-trained network. Okay, but the question still remains, why are architects so obsessed with discussing AI and creativity? Because this has been ongoing now for almost 2 years. I think that it seems that the discipline considers creativity a core competence, and that there might be a latent fear that we could get potentially displaced by an entity that we do not understand entirely. But I also have to say that the AIs also don't understand us, right? And there's also what is understanding, right? When a neural network, for example, makes a move in Go, produces a painting or creates a floor plan, it is not aware that it's being creative. Yeah? Actually, it does not have a concept of what it's doing at all, creating an ontological conundrum of creation without semantic meaning. Yeah? What rather happens here is learning on the before mentioned ideas that I mentioned is that humans perform a robust pareidolia reading of the material produced by neural networks. That means, I don't know if I'm just briefly going to explain the term of pareidolia. Pareidolia is, for example, when you see faces in the clouds. So your mind is actually optimized and trained to see things in objects that are not animated. So what might be happening is that when we see those results from neural networks, we read them as being creative because it's our creativity projected into that image. So let's talk a little bit about the ethical implications of machine learning. Well, you all have seen this sort of machine vision examples where there's image segmentation going on and there's feature recognition going on. Of course, you can apply that also on construction sites. This is an example from two colleagues from the Hong Kong Polytechnic University that use a similar method, basically, and a graph on top of it, to, for example, examine the construction site. So they can actually say, like, there's this amount of concrete on the site, there's this amount of steel on the site, etc., etc. But of course, you can also use it in a more, I would say, darker way, in that you can use it as a method of surveillance for workers. So in this case, for example, the labeling is also what is problematic here. So when you say, like, this is the amount of productive, this is the amount of semi-productive, and this is the amount of non-productive people. Well, the guy in the middle in red who's resting is a non-productive. But the problem here is, do we know why he's resting? Is he maybe injured? It doesn't have anything to do whether he's productive or not. So there's like problems here that has to do with the labeling. And labeling is one of the major problems in general in AI. I would actually say that labeling is a political process and that we have to be aware that that is going to influence massively what AIs are going to produce in the future. Also including, for example, racial bias, or cultural bias. The majority of the neural networks, the majority of the data sets created today have a heavy bias toward Western culture and so on, because they're in the majority of the cases, they're made in the West. So in this step in architecture design, in architecture history, we have to be aware that we have the chance to change that, at least for the architecture discipline. If you're interested in these sort of topics, I can highly recommend books like New Dark Ages by James Bridle, or The Atlas of AI, Power, Politics, and the Planetary Costs of AI by Kate Crawford, or Ruha Benjamin's Race After Technology. All right, a little rundown now again on techniques. I'm gonna really jump over those. You have seen those probably already. Neural style transfer. Basically, you have a target image, you have a style image, and you can transfer an image to that. And we have used that a lot, for example, in designing urban conditions. I'm very excited about this imagery. It's a couple of years ago, but it's really interesting that right now, in the last couple of months, I've been addressed several times by larger companies interested into this kind of research to apply them in reality. And I think that more research is needed, specifically when it comes to urban textures and how they can be understood through neural networks, and how valuable information can be translated so that the images you're seeing here do not end up just as pure aesthetical representations, but also are well informed to provide better living space. This is a competition we did in 21 for the planning and design of Qinglai City of Mountain, River and Tower project. It was quite a huge urban design project, where we started to really interrogate in more detail how we can use this method to create urban design textures. Then 2D to 3D style transfer, where basically you can generate imagery and then influence a mesh with this image. This was done for the competition for the Austrian Pavilion at the Dubai Expo. Unfortunately, we didn't get it. We were really close, but we didn't. And then, of course, questions of 3D GANs. Like, how can you create a 3D GAN? This was another one of the experiments we did 2020. I actually spent the entire summer 3D modeling little simple house models. And then my colleagues at Computer Science trained actually a neural network that was able to examine all these models and then deform a sphere to create variations on my own design sensibility. And I have to say this was quite a successful experiment that, of course, is completely subjective. It's not objective at all, but we are working on doing this now in an objective fashion. Also, this one was published as a paper at the Arcadia conference. So if anyone tells you that they actually are the first ones to do a 3D neural network, no, it's not true. A little bit more about the robot garden, because we combined a variety of different design methods in the robot garden that go from 2D to 2D style transfer to deep dreaming. This was really fun. I mean, basically, for example, collecting fountains and steps and various satellite images to be able to generate a variety of images that allows us to design that garden, so to speak. I like this video a lot. It was recently, they sent me this video from robotics. This is how the robots see the garden. So I actually also like very much how machines have a completely different perception of the world. It's so different to ours. It's so alien, but still sometimes even more accurate than our way of seeing the world. Okay, so collecting satellite images, then like here's a variety of things we did, from 2D to 3D style transfer to hallucinating in the bottom line. And some of the results were really absolutely outlandish, and I love those ones that are really strange and weird, because I think this is how machines really want architecture to be. One where we use StyleGAN. Do I have still a bit of time, Philip?
Yeah, take your time.
Okay, great. So this is a more recent project where we were actually looking for methods of how to take results from a StyleGAN, from a latent walk, and really create a 3D model out of it in the most straightforward possible way. So we created a data set on brutalism. We had a site in the center of Vienna for a shopping center. It's actually the Generative Center in Vienna is quite well known at the Marienhilferstraße. It's a building from the 70s that really needs remodeling or redoing. So we created that data set of images. Then we trained it. Then we had a ton of training results. I mean, that's the one thing that is quite amazing about all these processes, that they create like hundreds of variations. And then nonetheless, it's still sort of like the task of the architect or the artist to select the ones that he or she thinks are the most successful ones or the most promising ones that can help in finding an architectural or artistic solution for whatever you want to show. And then we used pixel projection to generate the building out of it. And we were surprised about like the very massive architectonic quality that right away was extracted out of this process, and then used that resulting model and worked further on it. So it's not entirely like 100% AI driven. But we're like really trying to introduce that pixel projection process right into our code so that we can end up with a 3D model right away instead of having to have an in-between step to do it. And that was the design of the Generative Center here. It's actually an office building / shopping / culture building. So there's a variety of functions included here. So that's basically, so this is, for example, an image where you can see what we modeled manually afterwards and what was really provided by the pixel projection process. And another one, I hope that I'm gonna publish a longer article about this project soon, which is basically an interesting project commissioned by an Austrian neuroscientist who really saw with a lot of interest what we've been doing in terms of neural networks and design, and thought like, okay, that's awesome. I want a house that represents my discipline and how actually that can be used in architecture. So He's an old architecture fan, so he was really fascinated by it. But one thing he wanted, very particularly wanted, he wanted that we use mid-century modern imagery, facades of mid-century modern houses and plans, and see how that whole process can extract those features and assemble them into something that is different. And the emphasis was on different, not on new. New is really quite an interesting and heavy problem to discuss. Again, a whole lecture on its own. I'm going to leave it there. So he wanted something different. And we played around with the different results we got for plans and elevations. And then using a similar method to what I showed just before for the Generative Center, we created the model of the house. And this was very exciting for us because the results are really promising. It has something very, I mean, it has definitely those modern features. It has definitely those mid-century modern features, but it's different. It's not the same. It's not a copy. It's not a specific architect. At the same time, there is enough of what I described before as estrangement and different and defamiliarization present here to make it an interesting and exciting project. So I'm coming to an end now. Just quickly, I want to also tell you that I founded the Neural Architecture Group together with Daniel Bolochand and Emmanuel Ko, where we try to meet on a regular basis and discuss new exciting things and ideas and concepts and criticize our own work. And then there's the website aiarchitects.org, which actually collects a whole set of different people interested into all those topics that I was discussing today in this lecture and more. And we're adding more people regularly. And of course, there's the ARI laboratory, which is sort of like my home base for all the research that I'm doing. Very important for me is that after some years of doing AI research, more or less like a guerrilla war, I got the laboratory that institutionalizes the research and allows us also to expand it in a more concise and serious fashion. There's also the YouTube channel that if you're interested, there's several lectures in there from the last years that I've collected and uploaded there. But there's also a bunch of tutorials that you can see in there about basics of Python scripting for AI. As mentioned at the beginning, I would like to thank again Philip for giving me the opportunity to present some of the ideas that are present in the book Neural Architecture. It should be available in the next couple of days, I think. This was already published recently, the newest edition of AD, Machine Hallucinations, Architecture and Artificial Intelligence, where I had the pleasure to co-edit this edition with Neil Leach. And in fall, there's going to be the release of this book here by Springer called Architecture in the Age of Intelligent Machines, which is, if neural architecture is more sort of like a collection of thoughts and ideas, this book here is rather sort of like the technical manual for that. So it includes all the neural networks described with its mathematics and with the code, and really goes deeper into what those things all mean in terms of the technology. Yes, thank you very much for having me. I know this was a lot in very short time, so I hope we can have like a very interesting conversation coming up now. Yes, so thank you very much.
Thank you. Thank you for Matthias' lecture. We can see the energy from Matthias over the past 3 years, especially from after 2020 span, actually generate a lot of engagement into the artificial intelligence research, and especially make a lot of demo in the architecture discipline to implement different algorithms in the scenarios of architecture design. So I think we have a lot of questions, probably need to make some discussion with you. And most importantly, because we have some figures like Neil make a speech months ago during the lockdown Shanghai to our school, and also a lot of critics to his lecture. So we want to argue in that lecture, he's talking about AI and creativity. So that's, you also mentioned a little bit on that, but I think we need to go even further about what is creativity, what is new, you mentioned in architect design. So it's like a searching or finding process when the designers try to introduce the AI algorithm to the design process. So actually, the question still goes to the demos or the examples right now, what you are doing and the other architects, pioneer architects doing, actually, which is based on the learning on the original exist images, including the big data, including the how many images we need to feed to the algorithm process. So we need to do a lot of things that's already exist, and just like the disco diffusion you mentioned, which is from the signifier, actually including some words to define different kind of latent space to searching some image which is not exist, but actually based on some existing images. So could you analyze a little bit on this kind of process? I think the AI design right now is like a new process, although it's kind of black box process. People never understand how to searching such kind of images in the black box. But actually, this is based on the original existing image or the pictures which in the internet or in the big data existing libraries. So if we want to know something real different, something novel, something new, so is that existing the imagination or the images which exist in the world?
Thank you, Philip. That's actually an excellent question. I already hinted on it a little bit. So first of all, you have to clarify a couple of things before we can go deeper into the question. Like number one, for example, is that like newest research actually shows that our mind almost actually operates like a giant remixer. So we have a very, very hard time to recognize something really new to us because we don't have a reference model to understand what is new. Yeah. So that's why like things that are a little bit more familiar and common make us feel more comfortable. That's also why I like to discuss, for example, things like defamiliarization and estrangement and so on, because those concepts, Sigmund Freud also wrote about that very interestingly. Those concepts are things that are familiar enough for us to recognize, but strange enough for us to be provoked by them. Yeah, that's what good art actually can do. Yeah, and if you think about that idea that like the concept of the new is very strange. Like it's at least when it comes to really very specific things. Like for example, I think Margaret Borden, Margaret Borden actually differentiated between the things like historical innovation and psychological innovation. I think these two areas, right? And she differentiates that in a way that psychological innovation means you basically created something new, but it's only new to you. Yeah, so it's actually other people might know about this. It's not really an invention, yeah, but it's for you, it's new. And then the other one, the historical innovation, which actually is really something that is completely new to the entirety of humanity, which is really difficult to achieve and happens very rarely, actually. Yeah, things like I think I wrote about this in somewhere that things like, for example, you know, Newton's laws of physics, that was really something new. Yeah. Einstein's relativity theory, that was really new, and most people still don't understand it. Yeah. I think that, for example, Le Corbusier's Maison Domino, like that concept of pilote and plate, that was really new because he understood actually how a specific material can be designed or organized in a particular way that no one before thought about. So, but these things are rare, very, very rare. And also it takes time for people to recognize them and understand that they're new. That's one part. The other part is about creativity. The question whether neural networks can be creative or AI can be creative. That goes back to another very basic problem we have, which is as long as we don't understand how creativity operates in our mind, what are the natural neural networks in our mind doing when we are creative, as long as we don't understand that, we cannot encapsulate it in mathematical formula. Thus, we cannot use it as a neural network, which means we don't know. It's very simple. Right now, the neuroscience status is we don't know exactly what happens when we are creative. And because of that, we cannot make a neural network that does it. So that's why I'm saying that when we think about neural networks being creative in the context of art or architecture, all the sort of things we're seeing now, it's more a projection of ourselves, like we're projecting creatively into the image we're seeing. Yeah. So it inspires me to be creative.
Yeah, I want to argue I don't agree with some of the part you mentioned. Probably the first part you mentioned, everything already exists in the latent space in order, which based on some understanding of human being. Maybe something already exists, you never noticed that or never reading such kind of data or such kind of system in your mind. So I think it's a little bit addressed the design my story into a postmodern image-based system because I think the knowledge including two parts. One part is just like Newton, I think this kind of scientific knowledge, which is fundamental to all the disciplines, including the artificial intelligence algorithm. That's a kind of fundamental knowledge, new knowledge system. But at the same time, we have some knowledge which already exists in different disciplines, which why the people need to be educated from the primary school to the university. You need to learn a lot of specific knowledge, which based on the experience or on the system, systematic ways how to organize. Like you need to understand the culture, the biology, and which have a very profound systematic initial logic knowledge system. So sometimes I think this kind of system make the information extremely complicated because it's based on a different dimension to reorganize the latent space. Actually, some of them are the original fundamental knowledge. Some of them are specific knowledge. So I think if you define everything just from the image-based thinking perspective, that will be a little bit superficial to understand the world, because sometimes something is not visible, actually hidden in the systematic ways how to reorganize the knowledge or initial logic of the creativity. So I think creativity sometimes is not visible. So the question to the neural network design is everything just focus on the image-based searching process. I think that's a little bit dangerous, I think, especially to the architecture discipline, because sometimes, for example, the social networks, when you make urban design, you need to understand not just the pattern of the urban fabric, which should be hidden in the social networks and the climate and the local tradition. Maybe the final result is a pattern of the urban fabric. But when you design, when you try to searching a certain kind of design, which located in a certain site, probably you need to analyze the process into certain process and to figure out the initial knowledge or the relationship corresponding to each other, which can generate a certain kind of design. But we mentioned urban design, for example, the design actually is the process we reorganize the system. Some of them by image is okay, maybe it's image of the urban fabric, but some of them is you cannot visibly present it. It's hidden in behind. So the question goes to, how would you like to redefine or rethinking on this kind of neural networks or the deep learning of the design process? Do you think the artificial intelligence tools can help us to review or to visualize or to represent all this kind of potential complexity in the design process or the result of design? I mentioned what is creativity. The creativity sometimes is not a novel thing. It's not new means creativity. Sometimes it's not new. It's just like you review the multi-layers, the relationship of them, and to find a potential detour which exists on the planet. So I think the novel probably thinking is a postmodern, which I mentioned, is signifier and signified representation thinking, which is quite structuralism. But I think the discipline evolution is very complicated, even more complexity right now, and the contradictions probably from the image base is okay. It's a solution, but it's not the whole system of the discipline. So I want you to analyze or to argue something about your thinking.
I mean, I completely agree with you that I mean, you cannot create you cannot design a city just based on 2 satellite images that you match up. I mean, that's of course not going to happen, right? It's just a first step. It's only a first step, because as you correctly mentioned, there's like a whole set of variables. There's a whole set of criteria actually that would actually comprise an urban design. I'm not even saying a good urban design, any urban design. Yeah, and because the question then also is, once you this is all of course dependent on the data you have and the data you have access to and the way you design your network and how they're actually operating with each other. So all these things need to be concatenated in order to really create a design that is holistic, that really takes more into account than, as I was saying already in my presentation, I was really looking into the aesthetics of it, but I know exactly that this is not a finished design. Yeah. But you have to start somewhere. And that's my point. My point is that you have to start somewhere so that somebody like you can say, well, yeah, but that's not all, no, is it? You understand? So you have to have a starting point where you can like kick off the research, the idea, because once you start, that's when you start asking questions. Yeah, that's when you start saying, well, it looks kind of cool, but does it really have some sort of value in terms of its urban qualities? Yeah. I think all of those is solvable, by the way. I don't think there's a big problem. I think that it's only a matter whether the architecture discipline has enough focus and enough will and enough power to really move ahead with these sort of design ideas. Because at some point, my main argument always is, if we as architects do not engage with these problems, with these ideas, with these concepts, somebody else will do it for us. Yeah, and we don't want to be as a discipline in that position. I can tell you that. Yeah. So I appreciate your criticism on the process, because I'm aware that there is much more to be done than what I was showing today. So in my opinion, we are at the beginning of something. We're not at the end of something. It's just the beginning. And to your point about postmodernism, because this is a really interesting point for me. I can tell you that the neural architecture group, we have had meetings where we discussed really like, is this, I mean, if we think about it like really deeply, it's a postmodern method. Yeah. And we're like, oh my God, really? Not again. But I think that's why I make this argument about estrangement, defamiliarization, and so on, because that adds another dimension to that discussion. It's not like this sort of imitation of the past because of nostalgia, right? It's really like what you were saying, it's exploring the latent space of that past to find hopefully innovative solutions for the future. Yeah. Yes.
It's just a discussion. I think why I name as a postmodern, maybe it's a postmodern, postmodern, because I think it's quite image-based because it's like a linguistic system. It's quite a structured linguistic system to me because, although it's hidden in the latent system, you just make an option which maybe already exists on planet, and the AI help you to figure out, visualize this kind of potential possibility. But it's totally image-based thinking process. Although what you're doing, you mentioned from 2D to 2.5 dimension to 3 dimension, and the generative process, you mentioned like the pixel projection, which from different direction can generate a 3-dimensional spatial experience. But I think it's still it's an image based generative process. It's a stylistic, or I can name it as a new formalism. And the formalism, although it's different to the Peter Eisenman's stage, which is the geometrical base, but right now AI makes like image base. It's much more higher dimension or multi-dimension compared to that what they're doing, but there's still a linguistic system. What I mentioned right now, the word is so complicated, is so my point when I launched the artificial intelligence journal, I mentioned I don't think this kind of artificial intelligence in architecture will be addressed in such kind of formation. Maybe at the very beginning, it's from the stylistic, like Zaha did. She actually just stylistic generative style, but Patrick actually goes to the parametric system. That is something a very long time to make research on the parameters on the protocols that which can influence the geometry system. But right now, like AI is similar. I think artificial intelligence is there. It's fundamental knowledge and from the computation discipline, which will profoundly influence a lot of disciplines and the process of thinking, the process of making, the process of constructing in architecture discipline. But I think we need to figure out the initial process or scenarios which address in a lot of very detailed and profound knowledge and already existing knowledge system to optimize them in a very long stage of history. So I think we should be a little bit more focused or rethinking on how to introduce artificial intelligence into architecture. That is, yesterday we have another conference named 3D Printing Conference organized by the Civil Engineer School of Tongji, and a lot of expertise from ETH, from different universities coming and make lectures. I think, for example, the robotic fabrication, we have a lot of very profound research that is not just about the form generation, which is about the optimization of the, for example, the tool paths, for example, the materials, materiality. They implement the AI in such kind of take care of the data. For example, how to find the right material, the protocols between the fibers and the ceramic and the water should be based on a lot of data that is extremely big data. They need to searching which is the best option, the optimal option, and then that is also a GAN image-based research process, but address this kind of process into a material, finding a new material. I think that is interesting for the artificial intelligence, actually, which will address into a lot of profound detail or specific knowledge research into our discipline. So, so my understanding is that probably what's the existing knowledge is still very important. We still need to educate the students. They should learning what is fundamental, what is basic, systematic ways. All the knowledge exists is you need to learn them. At the same time, you need to integrate or to introduce all this kind of new knowledge into that process. So I mean, the augmentation of artificial intelligence is to the design process and the construction process. It's augmentation. It's not just the creation. So I think the create a form or the form-based manifesto should be in the very starting time or the very early time of when new knowledge goes to the other discipline. But actually, the very long way of profound possibility or potential possibility is hidden behind. So that's why I think the Artificial Intelligence Journal is trying to introduce all these kind of scenarios, implementations in the future to augment the design and the construction. So that's my point. Actually, I'm quite open to this artificial intelligence to architecture, but at the same time, I'm a little bit like conservative. Still, we need to standing on from the discipline perspective to understand the new knowledge. So I don't know if you agree on that. Yeah.
Well, I'm trying to provide to disciplinary knowledge. I mean, I'm not, this is what at least I'm attempting to do so. I'm not sure if I'm achieving it, but I'm trying, yeah? Because I noticed when I really started to dig deeper into possibilities for an architecture, I figured that there is no theory about it. There's no idea about it. There's just hunches or visions, I would say maybe, but no like serious research. Why is it? How is it? When will it? Like all the things that make an interesting architectural concept. Yeah. So the one thing I want to make sure is to that you understand that I'm totally aware of what you're saying. Like that there is. That of course AI and neural networks can be applied in a very functional role in order to improve building. Yeah, I'm totally aware about it, but at the same time, I see this as just another possibility, and then there might be other people who want to write about it or do it. Yeah, so I have a field that I'm researching and looking into, which is design and culture and the way how AI is changing us as a discipline in this area. Yeah. And there might be other people who are going to look into optimization possibilities and all. So, but it doesn't mean that I have to do everything. That's what I'm trying to say. Also, if I would try to do everything, it probably would be really bad because then it would be just very superficial. Yeah. So I'd rather focus on one part, try to do my contribution there and discuss things that I think are interesting in terms of architecture as part of culture and not necessarily as part of the construction industry.
Mm-hmm. Okay,
by the way,
yeah.
One does not accept the other. What I'm saying is, culture and construction, they're basically the same thing. There's just two sides of a medal in architecture. Yeah, but so I'm not dividing here culture from building.
Mm-hmm. For sure, I think what you're doing make a lot of contribution to the discipline. You are one of the pioneers in the world who actually introduced artificial intelligence into architecture design. I think, and actually you're showing the potential possibilities for this kind of formation, which based on the black box and to educate and teaching the AI machine to imagine and to produce certain kind of the new profound possibilities for architecture future. So I think that's a contribution apparently, but at the same time, we always have to like to criticize on the pioneers. So
yeah, no, that's I hear you. I know, I understand.
Okay, so I think that's really special. Especially, I think you make a huge progress in the last 3 years, and that's just a very early starting point for the artificial intelligence in architecture. Very early, I think we can imagine, we can see in the next decades, AI will play much more important roles, from the thinking process to the imagination process and also creativity, for sure. Mm-hmm. I also believe in that. So we can see it's like a profound systematic things which will totally redefine our discipline. So thank you for the lecture, and we always want to see next. So we're looking forward to your research going even further. So any questions from the students open floor, welcome to put forward. The students?
They're probably still processing. Takes a bit.
We have a lot. Yes, we have a lot lectures recently,
yeah.
And we have 15 PhD candidates who make select these courses and need to write papers and based on the lectures. So looking forward to read some of them. And thank you, Matthias. I think it's great. And,
you're welcome. And yeah, if anyone is interested to know more, feel free to come over to Michigan. Take a course, yes, or join our lab, be a PhD student, whatever you like.
Great. Looking forward for the further collaboration, and also as a co-editor, looking forward for your support to organize the new essays who are interested in the artificial intelligence in architecture.
Absolutely. So thank you again for the invitation. It was a pleasure. Very happy that I was able to deliver this lecture for you guys. And I hope to see you soon somewhere, Philip, hopefully.
Yes.
Would be great.
Looking forward to travel again. It's a long time no travel.
Yeah, it has been a long time.
Thank you. Bye-bye.
Bye, everyone.
Bye-bye.